So now that you know something about the Executor interface, and that something is pretty darn simple, let's talk about how you can implement the Executor interface. And you'll see that there's a whole bunch of choices. You can choose fixed size thread pools, cached thread pools, work stealing thread pools, or even custom thread pools if you so desire. As I said before, the Executor interface can be implemented by a whole bunch of different techniques, all of which, of course, implement the Executor interface. There's also this concept of Executor configuration, which is typically performed in order to select or dictate the execution policy for tasks that are passed to the Executor implementation. And let's talk about some of the different execution policies that exist. So one thing you can do by execution policy is determine in which thread a task will be executed. And there's different choices. You can have an implementation where you'll have to use an existing thread in the pool. There's no new threads to be created. They're all fixed ahead of time. That would be, of course, the fixed size thread pool model. You can also have a policy where you can have a new thread created and added to the pool. That would be the cached thread pool implementation. And there's so on and so forth. There's sort of no end to the different alternatives because you can make your own custom implementations, so you're not limited by anything. As I mentioned before, there's even a single-threaded implementation of Executor, but it's kind of pointless. Another thing you can determine is which order tasks will be executed. Tasks could be executed in first in, first out order or FIFO order. Tasks could be implemented in last in, first out order, like a stack. So this is like a typical queue. A FIFO is like a queue, a typical queue. There's different kinds of queues, of course. You could have LIFO, which would be last in, first out. That's like a stack. And you could also have priority order, which would be a priority queue. Another thing you can determine through policy is how many tasks can run concurrently. And the question here, of course, as we've alluded to in earlier discussions, is what's the maximum number of tasks that you can have running concurrently? And how is that limited? Is it limited by the number of CPU cores, by some other determination that you decide to have because you don't want to have all your cores being used up for this particular thread pool implementation, and so on and so forth? Another question is, what happens if you have too many tasks for your system to handle? Should it just fail silently? Should it throw some kind of rejected execution exception? These are also choices that you get to make as someone using the Executor framework as to what you want the behavior to be. Another issue is what actions, if any, should be performed before and or after executing a task. So for example, in Android, in their async task framework, they have these hook methods called on pre-execute and on post-execute that get called before the task starts to run in the background thread and then after the task is finished executing in the background thread. So that's another design choice that you can make. So those are just some of the implementation choices, and the way that those choices are manifest is based on the implementation of the Executor interface you either choose or implement, and then the policies you can set on those. And we'll talk more about those policies as we get into the details of the different implementation choices.